All right, guys, I started making this video and then an announcement came over the PA, so some stuff is already written. So I'll kind of walk you through what I've got written here. So it states that small cube is cut out of a larger cube, so we should know what the volume of a cube is. Volume of any box, three-dimensional shape is length times width times height, but if all the sides are the same, it would just be like side times side times side, which is side cubed. Okay, so that's what we're working with here. And we've got this large cube, which has a dimension of x, and then we're cutting out a smaller cube. So the volume would be x times x times x, which is the volume of the larger cube, and then we're subtracting away the volume of the smaller cube because that's being cut out. So this will be the volume of that strange shape, and we were told that it was 23,625 cubic centimeters. So that's the first equation that we can set up. Second equation we can set up, is what I have underlined here, and it says the length of the smaller cube, which is y, is 1/2 the length of the larger cube. So that's this equation right here. Rather than dealing with fractions, which I'm sure a lot of us don't want to do, we can multiply both sides by 2 here, and we can get 2y equals x. All right, so what we're going to do with that is we're going to do a little substitution. We're going to take this right here and sub 2y in for x in that equation. Okay, so for the volume, instead of x, I am going to write 2y cubed minus y cubed equals 23,625. Okay, so with that equation, what I am going to do is simplify this up right here. So 2y cubed is 8. Like 2y quantity cubed, we get 8y cubed, and then minus y cubed gives us 7y cubed. So we're just solving this equation at this point. All right, so we're trying to get the y by itself. So we're going to divide both sides by 7. So when we divide both sides by 7, 23,625 divided by 7 leaves us with 3375. And then what we do to get the y by itself is we cube root, because this is being cubed. So the opposite is to cube root. It's just like squaring and square rooting. So let me show you that button on the calculator. See next to the square root. The square root is in blue, and then it says n root x. So hit control and then hit that button. And the root that we're taking is the third root, and then hit tab, and we're taking the third root of 3375. And what we come up with is 15. Okay, so y equals 15. That would be the length of the smaller cube. And then it says that x is twice that. So x would be 30. And we want units, they're both centimeters. Okay, so those would be your dimensions for the first one. The last thing we're doing, and this is a pretty brief video here, the last thing we're doing is something called quadratic form. Quadratic form is any expression of the form a u squared plus b times u plus c, where u is an expression of x. Okay, so you'll see what I mean once we start looking at this example. So example 5, it's going to kind of look like it's in quadratic form. So this middle term is supposed to be b times u. So that means in this case, our expression of x is an x cubed. So I can write this by taking the 2 out fronts, and then the x to the 6th is x cubed squared. Okay, we're kind of using those exponential properties to rewrite that. And then minus x cubed, and then plus 9. So see how I've got these terms in parentheses? Those become like the u right here. So we've got a u squared minus, and then b. So we could technically have like a 1 b times u and then plus c. So that is what we mean by quadratic form. So kind of writing it in a way that you could factor it with your normal quadratic rules. All right, this one. We've got x to the 4th. So if we say that our middle term, because whatever is in the middle here, that's always just going to be u. So u squared should be x to the 6th. But this isn't an x to the 6th. So this is not possible to write this in quadratic form. So whatever this term is right here, it should always be this term squared. And if I square an x cubed, I get an x to the 6th, not an x to the 4th. Okay, so we're going to go through an example of solving by using quadratic form. So this one, my x squared, that's my middle term, so that means u equals x squared. And if I square that, I get x to the fourth, so this is in quadratic form. So let's write that. So x squared squared, that's what I can write for x to the fourth, and then minus 29 x squared plus 100 equals 0. Okay, so just like I solved my quadratic equations, when I have 0 on the right, I can factor this down. And once I factor this down, then I'll be able to solve by factoring. So I start with my two pieces here. Okay, instead of being x and x, it's going to be x squared and x squared. So if I multiply these two together, I get x squared squared, which is what I'm supposed to have right here. And then I want to multiply to 100 and add to negative 29. And that would be a negative 25 and a negative 4. Okay, so now that I've got it factored originally, I can actually keep going because both of these are the difference of perfect squares. So this, I can start with, again, x and x. I can do the same thing with this one. Start with x and x. Okay, here, to get negative 25, I have negative 5 and positive 5. That's the difference of squares pattern. Same thing here, negative 2 and positive 2. Okay, so now I'm going to get 4 answers. If I set each one of these equal to 0, if I set x minus 5 equal to 0, I get 5. If I set this equal to 0, I get negative 5. This gives me 2, and this gives me negative 2. So I've got 4 answers here. I think that's it. Yep.